Okay. So for this first one, for the section 1-3 problem solving, you have equal number of boys and girls. If 8 girls leave, twice as many boys as girls remain. What's the original number of students? Anybody like to take a guess at that? What did you get?
32.
32. Very good. How did you go about it?
Well, I knew it had been even numbers, so I started saying numbers greater than 20.
Mm-hmm.
And I just, by trial and error, subtracted 8 and then divided by 3.
Subtracted 8 divided by 3. Anybody else try something different? That wants to share? Okay, so what I did is just said,
Right.
huh?
I said I tried something different, but I didn't get it right.
32 was the answer. So if you got that good. Now, that was her method. What I did is I just said, and I'm going to jot it down just so you have something to go by in case you didn't. Girls are half the number of boys. Okay, so girls are half the number of boys, so that means 16 boys. Right? Then if you know that you have 16 boys, then you have 32 total students. Okay? So the next one we're going to look at, and I'll give you I gave you a second to look at this, is find the missing digit x. And anybody want to take a guess at that? I'll tell you, x is 0. If you feel pretty good about your answer, share how you got that. Or talk to me about what did you try. On this, usually I try to find a pattern. I look at the row and see if there's anything going on. 3, 2, 4, 8. Not really anything by adding, because we're used to yesterday's lesson. We looked at patterns. Looked at the next row, 7, 2, 1, 3. Nothing consistently going on with that, adding the same number or multiplying the same number. So then I bail on that. Okay. My next thought process was, well, maybe try columns. 3, 7, 8, 4. Nothing arithmetic or geometric sequence wise. Then I kind of look at a diagonal. 3, 2, x, 9. Nothing there. So I'm like, okay, clearly not anything to do with some type of arithmetic sequence, not anything to do with a geometric sequence. So the next thing you can do, and this one was just tough because I have to basically show you how to get there, is I want you to look at the first row number. Just look at the first row, 3, 2, 4, 8. I want you to look at the first number and the last number. 3 and 8, right? Okay. Then on the second row, 7 and 3. 8, 5, 4, and 9. Does anybody kind of start to see anything there? Not yet? Yeah, this one's tricky. This one's tricky. So let me bring you back up to the first row. Hang in there with me. 3 and 8, right? What's 3 plus 8? What's 3 times 8? You see it? What's 7 times 3? 8 times 5. 4 times 9. Yeah, they're wrong for that, huh? So it's like I told you. But now you know it's in your toolbox. Now you know. I try the easy, intuitive stuff. And if not, here's one thing I'm going to look for now. I'm going to look to see if they're doing something on the outside to get something on the inside. And that's what I said. This. So we multiply. So we'll do like this. So we'll say 3 times 8. I'll circle this. Equals 24. 7 times 3 equals 21. We saw 8 times 5 equals 40. And then we have 4 times 9 is 36. And so this was what we were looking for. So x is equal to 0. Okay. This one's always fun too. 26 volume encyclopedia. One for each letter, A through Z. Okay. It's on a bookshelf, alphabetical order, left to right. So you start with A on the left and you're going to go to Z to the right. Each volume is 2 inches thick, including the cover. So the whole book, 2 inches thick. The cover is 1/4 of the inch. A worm eats through the beginning of the inside front cover of A and ends after eating through the back cover of volume 2. How many inches did the worm eat? And I'm missing a Y there. Whenever I copied it. Fix that. How many inches did the worm eat? Okay. Now, I'm visual, so I'll try to draw a little bit of a picture. Is it right off the bat? You might would have a guess at this. Anybody have a guess right off? It's okay to guess and guess wrong.
Is that a 2 or a Z?
A 2. Oh, Z. You're talking about this one?
It says from
Let's do
volume
this.
A to volume.
Let's do that. Z. It actually does look a lot like my 2s. Okay. If I drew that, I'm just going to put dot, dot, dot in the middle because, so how many of these do we have? A through Z is 26. So actually, 26. So let me do this so I can, how many are in the middle? 24 of them in the middle. Y'all okay with that? So you sketch however you want to sketch this. I'm just going to start with my first one represented. My second one, it's on a bookshelf. I know there's 24 of them in the middle, B, C, D through Y. How many inches did each worm eat? Now we know the whole entire book is 2 inches, right? But he says he starts where? Inside the front cover. Okay. The first part's easy though, right? So if I take 24 times 2, that part's easy. This whole inside middle is 48 inches, so we know for sure he does that. But what we have to get is, so my worm is here, and he starts through that. Starts through the front cover, so how much does he get at the front cover? He starts the front cover of the book. A 1/4 of an inch. So the tricky thing is because, and this one got us too, until we physically did it. I said my first book here, right? The front cover of my book is actually right here. So if he starts there, he doesn't do anything with this, right? I know. So if you visually see, let me get a video. So you'll start here. We start at this front cover. So this is just a 4. So I'm going to just represent my worm there, and it's going to get the first little binding. So it gets a 1/4 of an inch for the front cover. And then it's going to eat through those 24 other books. And then where does he say it finishes? Eating through the back cover. Okay, because the same idea. Now, once he gets through the back cover, he stops. So, right, there's 2 books here. He started through A, but now this is my last book. Back cover's here. So he doesn't get this part. Right? So that means he's going to get a 1/4 of the inch of the back cover. So total, he's going to eat 48.5 or 48 and a half inches. Actually, that's fine. Okay. So visually, like sometimes we have to learn to talk to ourselves in math. You have to learn to like sometimes we visually like kind of draw stuff out or touch stuff. It helps. The next one is a cat woman has many cats. You ask cat woman how many cats does she have, and she says, "I have 5/6 of my cats plus 7." How many cats does she have? I do know how to spell many, by the way, but when I delete my answers, I grab everything else, I guess. How many cats does she have? 5/6 of my cats plus 7.
So we would try to do like 5/6 plus 7, where 7 is in fraction from 7/1.
But so your guess is 7? Is that what your guess is? Good guess, except for you didn't factor in the you're kind of close, but you didn't factor in the number of cats that we don't know necessarily. So you'll have a variable in there.
Plus eggs.
Kind of. Mm-hmm. So, and this one's tricky because different people, when we've had people answer this one, they went kind of all different ways with it. But if I have to do, let me go in a different color. And I'll try to give you things that you can write down and keep. So if you let n equal the number of cats, because we don't know what that is yet, and we try to set up to some type of equation or something to be able to represent that, we would have the number of cats is equal to 5/6 the number of cats, because I try here 5/6 of my cats plus 7. Well, that's what she told us. We said, how many cats do you have? He said cats are n. She says n is equal to 5/6 of my cats n plus 7. So basically we just have to solve this. Okay, so we're trying to get n by itself. If you remember this before, we're just going to move everything with an n to one side. So I'm going to move 5/6 to the other side by subtracting it. So now I have 1 n. You can put 1 as a placeholder. But 1 minus 5/6, remember 1, if I rewrite 1 as a fraction, 6 over 6 is just 1. Minus 5 over 6, just getting a common denominator, that would give me 1/6 over n is equal to 7. Okay, so you can go off to the side and do scratch work to get a common denominator on your fraction. And then for me to simplify this, if they multiply by 1/6, we can multiply by the reciprocal, which is 6 over 1. And we'll get that n is equal to 42. And that's cats. So those ones that are tricky like that, for me, what works for me is to try to set up an equation that describes that and then solve the equation. I have a couple people that just in their mind figured that out, just thought that way, and I was just like, okay. I tend to be visual, and I tend to be very, I like to use equations to solve stuff when I can. Okay. All right. 13. A gas gauge reads 1/8 full. 15 gallons were added. Then the tank read 3/4 full. How many more gallons are needed to fill the entire tank up? Same thing as 11, and one of the things that makes it difficult for us is they'll throw fractions at us, so it's a little bit harder for us in our mind to kind of visualize like the fraction component of it, especially because they don't even give us fractions that have common denominators at first. So the comparison might be a little bit tough for us. So we're going to try to do something similar with 13 and try to write an equation that represents that. So if I have, I'll just let F be full, okay? And what I do have is, if I have 1/8 full, I have 1/8 of a full tank. I'm just letting F be full tank over here. F equals full tank. Okay, so that started out. It says 1/8 of full. Then what did they do after that? Added 15 gallons. And that gave us how much? That got us to 3/4 full. Then our first task is to find out, well, how much is full? So if we find F first, it's a good starting point. So we just said, all right, we know full. We don't know exactly what full is, but we know full, and everything else about the problem was based on full. So identify a variable and then apply the information to it. So here we are. Now let's algebraically solve for F. Now one of the things, if you're not, if you prefer not to work with fractions, you can get rid of the fraction first. Let me not use blue. Let's do multiply by the common denominator of 8, and this will take care of your fractions, so you don't have to deal with fractions anymore. You don't have to do it this way. You can work with fractions if you prefer. But if I multiply through everything by 8, I won't have any more fractions. So 1/8, that's just going to reduce to F. 1/8 times 8. 8 times 15 is 120. And then over here, 3/4 times 8, if I did the scratch work to that, remember, divide by 4, 2 times 3 is 6, 6 over 1, so that's just 6, F. Now, I don't have any more fractions, and I can kind of just work with these whole numbers. So let me move that scratch work out the way. Okay? Now, I want to move everything that has an F on the same side. Okay, so if I move this F over here, subtract F from this side, subtract F from the other side. 120 is equal to 6 minus 1 is 5F. To get F by itself, if they multiply by 5, we what? Divide both sides by 5. So 120 divided by 5 is going to be 24. Well, full is 24 gallons. We found out that, but the question is, how many more gallons are needed to fill the tank up? How many more gallons are needed to fill the tank up? First of all, we need to figure out how many we started with. How many did we start with? 1/8 full, but we know what full is now. So 1/8 full is 1/8 times 24, which if we put that over 1 and then reduce, divide by 8, then 1 times 3 is 3 over 1, which is just 3 gallons. Okay, 3 gallons is what you start with. Then what did they do? Added how many? 15. So we're at 18 gallons. How much is it for full? 24. So how much do we need to do? What do we do to figure out what we need to put back in there? Subtract that from 24, right? So then we take full, subtract the amount we know we have to get 6 gallons different. So we know we need to add back 6 gallons to make it full. So don't be intimidated by those. Okay, I know that kind of seems like a lot, and it's up front. It's hard for this class to hit us with this lesson, bam, right out the gate, because it is one of the tougher ones because there's no exact way. There's no, you have to do it this way, and there's tons of different problems filtered out you. So I can only give you things to prepare you. So the method for 11 and 13, your takeaway is when it gets like that and you're like, whoa, I don't even know what to do. My advice to you is designate a variable to do something, to name something you do know, and then write an equation about that variable. Solve for that variable, and then look back and see what else you need to go for your next step. So that's going to be your tactic. That's your tool in the toolbox for these types of problems. And like I said, it's not the only way to work though. I'm just giving you things to work with, okay? What's the relationship between the rows? Okay, so here we go again with that stuff. 18, 38, 24, 46, 42. It wants you to compare. So it did say between the rows. So it wants you to compare the top row, which I just said, and look at it in relationship to the bottom row. And just because addition and subtracting is easier for her, I probably would have tried 18 plus 8, 38 plus 24, 24 plus 8, see if anything happened. It doesn't. I tried to subtract 18 minus 8, you get 10, 38 minus 24, you get 12, 24 minus 8, well, that just threw that out. So, no. So then I'm going to try something with multiplication. And I already knew last time they kind of threw a weird thing at us, so does anybody see it? What happens if you multiply the two numbers in the numerator? What's the first one? What's the first two digits? What's the digits in the first number? What happens if you multiply them? 1 times 8? 8. What about the next one? 3 times 8? 24. 2 times 4? Like, so.
Like, it seems so complicated.
I know, I know. Okay, so here we did 1 times 8 is 8. So here we did 3 times 8 is 24. 2 times 4 is 8. 4 times 6 is 24. And 4 times 2 is 8. Multiply, so our relationship is multiply top digits to get bottom row. Bottom row, no, bottom digit. I'll say bottom number. Yeah, so tool in your toolbox. So you'll, like I said, you'll be familiar and you'll kind of have a little bit of a heads up. So when I randomly pick through any of the problems, I try to find the stuff that was tricky. Cindy was asked to subtract 3 from a certain number, divide the result by 9. Instead, she messed up, subtracted 9, then divided by the result by 3, getting the answer of 43. What would her answer have been if she worked it correctly? So she messed up and she got 43. But they're saying, like, what would she do to get the correct answer? Let's see. So first of all, when we do this, let's just talk about what Cindy did first. She did, because we need to know what she got, so then we can figure out what we needed to get. She did the number, subtracted 9. So she did the number minus 9, and then what did she do? She divided that answer. She divided this entire answer by 3. Is everybody with me there? See where I got that from? Okay. What did she get? 43. So let's play with what she got. Okay. So to work this one, you can put this over 1 and cross multiply. 1 times n minus 9 is just n minus 9. And 3 times 43 is 129. To get n by itself, if they subtract 9, we're going to add 9 to both sides. So n is equal to 138. So what we want to compare that to is where if Cindy worked correctly. We'll say if Cindy worked correctly over here. This is what she did, and this is if she worked it correctly. So subtract 3 from a certain number, then divide by 9. Okay. So we know we would have take a number, subtract 3, then divide by 9. And we said, what's that equal? Well, the number we found was 138. So if you take 138, that we found over there, we need to figure out what we can get there. So that's just going to be 138 minus 3. Nine goes in there 1 time. 4 left over, so 45. 9 times 5, 45. There you go. 15. All right, 25. What would the box folded up look like? I will tell you, this problem right here, I literally have people bring a piece of paper to the test and write this out and fold this thing up to answer the question. If you're that person, you're visually, like when we work over this and you're just like, what? That's because you probably can see it. If you see it, you'll get it, okay? It's saying fold that thing up, right? So if you take 1 and you fold it under, then we have 3, then you have 5 over here, and 6 will be on the bottom, right? If you was to wrap that all the way around. So visually, kind of be doing this with yourself. 2 flipped over, 4 flipped over, right? But what would be the box folded up look like? Now that's what our box is, but that doesn't mean they can't turn it for us to look at it and say, well, which ones of these works? So kind of play with that for a second. We visually can grasp where that thing's wrapped around, but can you tell me one that you can eliminate? Process of elimination is your friend in this. So let's just look at this. If I left it just like that and I let my 3 be on top, right, and I folded my 1 here, then that means, and then over here I have 5, and 6 would be tucked under. Okay. 5 and 6 are next to each other. 5, 6, 1 has to all be there. It can't be on the side of it. So what can I eliminate? Good. At least that. So we know we can eliminate D. Now do a similar thing in your mind with A, B, and C, and tell me if you see another one we can eliminate. Where did we say 6 would be if I did that same thing? Right? So look at C. 3, 4. Yeah, so you see that one? We can scratch that one out as well. C. So we already said here, here. Um, and the same thing for B. So our answer is A. If visually that's hard for you in your mind to like flip that box around and move it, then your fixes, bring you a scratch piece of paper and draw you a little box, tear it out, and when you fold it up, it'll be real easy visually, okay? If you have,
I thought it was B for a second, because it said 6 would be on the bottom, on the side.
The word power just says.
Yeah.
Are in the wrong places.
yeah. Yeah, so that one you have to play with because those are tricky. C and D is really easy, obvious, but then once you get down to that 50-50, that's where it gets to be tough. If you raise 3 to the 324th power, what is the units digit of the result? So, first of all, we don't know what 3 to the 324th power that number is going to be, so that when we get some number that we can name the ones digit, the digit, the units digit, right? So what we're going to have to do to start there is just see if we can figure out some kind of pattern. Okay, so we'll start with what we do know. 3 to the 1. 3 to the 2, that's 3 squared, which means 3 times 3. 3 to the third, 27. 3 to the fourth is 81. Okay, if I come over here, I have 3 to the fifth, which is 243. 3 to the sixth, 729. 3 to the seventh is 2,187. 3 to the eighth, 6,561. I'm just going to get us enough to see if we can find some kind of pattern going on here. 3 to the 10 will be 3 to the 11 and 3 to the 12. 3 to the 10 was 59,049. 122,147. So I just did that because I technically, if I didn't have the calculator for this to do it, I might not know how to get 3 raised to 324 to answer what the ones digit is, the units digit. But if I look at this pattern, I'm going by that, look at the units digit of each one. 3, 9, 7, 1. Next column. 3, 9, 7, 1. Next column. 3, 9, 7, 1. So we've established that it's a pattern and it happens in every, what, fourth one? 1, 2, 3, 4. So if you take the power, actually let me highlight this. So 3, 9, 7, 1. 3, 9. So our note will be, if we divide exponent 324 by 4, since the pattern cycles every fourth power, every fourth term, we would, when you divide that, you get a remainder of 0. So where we did 324 divided by 4 is equal to 81. No nothing left over, 81 remainder 0. So if you looked at that, you would have, oh wait, a unit digit of 1. Okay. So all I did with the section 1.3, the problem solving, is I tried to pull out the less familiar tactics for problem solving that you wouldn't. The patterns that were awkward and weird to us, but now that we know are a thing. Some stuff that might be kind of difficult, one that's visually challenging. So I kind of grabbed a math lab is going to just pull different stuff at you. So it's not that you're going to get the exact thing, but hopefully by the stuff that we covered today, you have some tools to work with, okay, to get there. Now, for section 1.4, section 1.4 in this text is, let me read the title of that one. It says calculating, estimating, and reading graphs. So using a 4-function calculator. So today that is the lesson, like plugging this stuff in the calculator. Okay. So wrote down the first one. Really, we're going to apply order of operations to this stuff first. So in this, we would do the 3.2 minus 1.1, and then multiply that by 2.8. Okay. Order of operations makes you do inside parentheses first. The next one is the square root of a decimal, right? So, let me see. Since this is all just calculator stuff, I'm gonna stop the video. Go ahead and plug that in, and plug number 3 in your calculator. The rest of this is just calculator stuff, so you can do that.